Hi, everybody. My name is Moody Hadi. I'm a senior director at S&P Global. And my topic today is about interactive data visualization and basically credit. So I'm going to go over a few bullet points and then go through a live demo. At S&P, we provide commercial products typically on the credit side. And we're looking at it typically from our user's perspective, not always from the data scientist or the quant's perspective. So in that area, there's been a lot of research, as you know, and a lot of prior art that's quite useful. And I'm going to go through basically a little bit around basically the current ecosystem, what are the major drivers around it, and then show you what we've been doing about it, like on a commercial level. Actually, one commercial product, two stuff that's in prototype form. So the outline today is I'll give you a bit of background around S&P, just in general, because it's a very large company. Show you some of the main drivers around data visualization, which this audience probably is quite familiar with. Kind of give you at least my perspective on the ecosystem today. Show you why interactive visualization is quite important in credit, specifically, and basically what S&P has been doing about it. So S&P Global is really composed of four major business lines. First one being ratings, then indices, then market intelligence, which is basically my department, which is a data analytics platform, and then Platts, which is focused around energy. Within S&P Market Intelligence, there's a risk services team, which is in my team, and we really focus on credit risk, market risk, operational risk. So our audiences are typically fixed income portfolio managers, credit analysts, folks who are quite technical, to be honest. But there's a balance, and you'll see that later. So, the first sort of major thing I would like to point out is that there's been quite a few leaps in interactive visualization over the last 5 years or so, and there are quite a few drivers to it. And I think I tried to sort of condense all the drivers into four sort of major items. I mean, obviously, as you guys know, big data, the size of the data sets, the velocity, the ability to process large transactions is driving the need for better ways to interact with it beyond just modeling, visualizing what you're actually looking at. Machine learning, so the algorithmization, basically, whether supervised or unsupervised, has taken quite a bit of leaps in the last few years, especially with basically the hardware sort of catching up into more specific, what they call them, tensor processing units and things like that. So it allows you to process that information and try different models that structurally were difficult to implement. I think one of the areas that's been going on for a while that's also driving this area, driving visualization and the level of interactivity you see today is reproducible research and analysis. So, I mean, when you build a model and you basically really feel very strongly about it, that's all great. But if somebody can reproduce it, it's not really worth anything, to be honest. So the ability for somebody else to take it, be able to replicate your results, understand what your rationale behind it is, and then parameterize it or play with the parameters in order to get a feel for it is quite important. And I think that is part of why the interactive level has gone up on the visualization side. I think last but not least is the open source community. We're not all very cheap. We can pay for things as data scientists. But I think the peer review process around basically the fact that there's so many packages and libraries and the ability to leverage the community for their expertise and specializations is quite strong. And to be honest, a lot of the open source packages have higher quality, I would say, than some of the commercial packages, and they actually get to update further and faster than what you would do on the commercial side. So that's really quite a huge boost to interactivity. So now, where does visualization play in this area? And the interactive visualization, I see it as a glue that's basically linking those four major drivers together. This is how you communicate to your end customer what you've done. And they have to be able to live within that workflow and be able to analyze it and work with it as though it's like an iPhone app, right? It's one of the simpler Uber apps. You don't need to know what the algorithm behind Uber is. You just know it works. And that level of interactivity and intuition is very important. And that's why what you'll see is actually was kind of difficult to do back in the day, and these days is quite actually simple with a few lines of code. When I look at and this is similar to what the prior presenter did, when I look at the ecosystem of visualization, really you see two sort of major segments. One, what I call passive, and then one that's like a bit more active. And I'll try to define them a bit. Obviously, we all know like the packages here, the team, everyone's familiar with Plotly, RStudio, Python, Shiny. So you know about reactive frameworks. You understand the level that the visualization has to be scientifically rigorous. And you understand the value of actually having out-of-the-box functionality, because nobody wants to necessarily code in JavaScript all the time. So, the passive segment is sort of a branch of business intelligence, which has been around for a while. And you can think of it as basically, you guys are probably familiar with data warehouses and data lakes and data marts. Think of it as multidimensional cubes that are pre-cached. And you can slice and dice that data, drill down, roll them up. But really, you're confined within the elements that you more or less pre-calculated. You can do some basic types of aggregations, but you cannot really build sort of a regression-based model or something within that framework. And obviously, that's fueling a lot of the business intelligence piece, but I term it passive because the real user is already analyzing existing data sets. They're not generating new data sets. In the active segment, where like Plotly, for example, plays a really big part, when you start linking it with supervised learning and unsupervised learning and things where you can actually tweak parameters, you can effectively generate data like in real time. I mean, conditional on the model being able to process it in real time, but and that data set never existed in a data warehouse or a data lake. That's something new that the user's IP, the user's qualitative assessment has actually influenced it. So you're really actively interacting with the model and the data and the input data and helping them basically provide their assessment, whether objective or subjective, depending on the use case. And in credit, it's a mix of the both, actually. So that's kind of like the active segment. And really, Plotly is a very good example of that. I mean, there were a few other branches like iPlots and things like that could do interactivity, but Plotly is by far at least the better tool. We took a lot of effort to actually identify them as a toolkit. So now the question is, why is this even important to credit? I mean, credit is not exactly the most exciting business, right? I think the most excitement people get is when they go buy a house and they meet the credit analyst or the loan officer or something, right? Really, the credit analyst's work is quite technical. They're very quantitative. They're really typically power users. They've got doctorates. They're ex-physicists, right? So they're quite familiar with the problems. The problem is that's not their job. Their job isn't to build a model. Their job is to manage risk, right? So they have to leverage outside models or internal models and actually be able to track them like in real time. So the last thing they want to do is have to understand why you hard-coded some parameter this way or not. They really just want to use it and move on, put in their subjectivity. And so there really needs to be a balance between what parameters you expose, how you analyze the generated data sets, and what options they have. Because at the end of the day, you want it to be intuitive without basically it ending up being overbearing, right? And I'm sure some of the financial engineers are familiar with some of the systems that can be overbearing. So you'll see like a lot of the effort that we've done at S&P is actually trying to think from the user standpoint, what are the key elements that will give them the most interactivity while still keeping the models and the quantitative side a bit under the hood, so that we're not exposing like every single parameter under the sun to them, because then they would just not use the system, right? So what I'll do is I'll show you through 3 different apps. The first two are, the first one is commercial, so it's publicly available now on S&P Global, assuming you have a license. Credit Market Explorer is a bond-based app that allows people, the clients, to basically link different types of bonds and construct their own credit curves in real time. And this is a prototype. And the credit transition states, you're looking at transition rates of basically pools of mortgages, so effectively large data. That third one, AppIQ, and in market intelligence, we have, this is like the ratings direct monitor. So you can think of this as almost a portfolio or a subset of portfolio. In this case, you're looking at basically equities type data combined with basically credit default swaps and the rating on the x-axis. And what clients are looking here for, they're trying to figure out if there are relative value opportunities. So this is a typical report that the street actually has. These are typically built in PDFs. So they send them out some research, you get something, and you look at it. What we've done is we've linked our data sets with some basically quite few models and published this out as an interactive tool. And what you can see is you can literally zoom in and zoom out and hover at certain elements. You can drag and drop pieces. And you can actually already tell that there is a convexity pattern to it, right? As the name gets in more and more distress, the CDS actually is not linear. It has like a curvature to it. The other nice piece is you can basically go in and start filtering by different sectors and really narrowing down any opportunities you want to look at. The great thing is you can zoom in and zoom out, and a lot of this in high charts and other D3JS-based packages, you would have to effectively code it with, Plotly, obviously, there's a lot of, out-of-the-box functionality that comes in, which is quite useful because, when you're on a commercial side, you really want to be able to push these apps out there quite quickly. The last thing you want to do is code something that's not quite strictly to the user, right? Strictly in your line of sight. So if it's a zoom functionality, I'd rather get it out of the box than have to build it. So this is kind of an example of an existing product. You can actually link different, basically, metrics and basically different dimensions to it. And then you're looking at basically, more or less three-dimensional information here because you've got the size. And then you can basically start building alerts around particular names. As you log in, it keeps track of what you've logged in and links the news to it. So it's quite looks contemporary, right, relative to the sort of the other more traditional applications. So you can really customize. So this is quite a simple way that's trying to communicate to users with as few clicks as possible what the relative value opportunities in the market are, right? So it looks quite simple, but actually there's a lot of depth behind it. And that's the general theme that you want to keep as you build more complex models, right? Like with the other prototype, it's a bit more complex. There's a structural model behind it. What you're looking at here is basically by currency, by sector, by rating, by different source providers. You can basically look at this is just looking at one day, looking at what the market's quoting in the bond area. And you can quickly see sort of some patterns around, based on these investment grade names, what's going on, what the term structure behaves. And what clients typically want to do here is they want to analyze certain clustering effects and eventually go into another area and then construct their own peer-based credit curves, right? So here you can imagine you're really just looking at more like the reporting side. You're really looking at seeing what the data is telling you, right? And you don't want the client to go in and basically just pull the data and do it in R. You want them to stick within that workflow. So once they sort of understand what they're looking at, they can move on to the next step where you've basically already provided them with an output of all the names that you have constructed. And then with just one click, you're actually they're building a model, right, in real time. So you expose just enough parameterization that allows them to basically be able to tweak it just to get them through the workflow that they need to get through, right? So 1 second, I will. Sorry, so I kind of really like this thing. So basically what you could do is this is kind of a level shift, as you can tell. It's sort of already shifting it by almost in parallel. It's not technically parallel, but it's close. And then if you start basically overriding sort of the curvature to it, you can go override the shape calibration, and then you can start, again, sort of fitting subjectively what you're observing, right? Again, quite simple. This is using Plotly and basically Shiny, and you can see it's very, very to the point, without having too much details around the underlying. Behind the scenes, there's 6 degrees of freedom running this basically optimizer. and a lot of data being calibrated to it. But you wouldn't know it basically looking at the app, right? Yeah. And the last two elements are really looking at like basically the review of the prices and the quotes that are coming out and save and restore analysis. Keep in mind this is a prototype, so it's not something we have in the public domain. Okay, for the last one, it looks fancier than it really is. Okay, so it's just a prototype. So, but in this prototype, you're really looking at transition rates on loans. So you're looking at basically terabytes of data, and we're really looking at Markov chains and seeing how they evolved over time. And really, I think the data set goes back to 2001. And at the loan level, individual like consumer loan level, residential loans, mortgages. And effectively, you can quickly analyze information. So here you're looking at basically the loan being at the current state and transitioning to sticking to the current state. There's 30-day delinquency, 60, 90, foreclosures, and then some restructuring or some basically recovery to it. So more or less that's the terminal state. And what you're really trying to do is really analyze the data by different segments, yeah? So you're really interacting with it, changing what types of loans you're looking at, zooming down into it, and then if you want to look at sort of the output, you can actually really look at it in here. I think one of the neat parts, and this is like, again, similar concept, you're analyzing existing data sets and understanding it. The next step is to really do something with it, right? And here, what you're actually looking at is basically the actual time series of the transition rates. And in real time, you can basically quickly build some simple models to see, regression based in this case, like of what's basically going on, right? And again, simple drag drop, like connectivity, switching basically to different types of loans. It'll take a little bit to compute and come back, but hopefully. But yeah, like it's very, oops, see, happens. Still a prototype. But, okay. No worries. So basically, simple kind of interactivity, and I think that's the level of sophistication you want to get to eventually. Like, especially in complex areas like financial engineering and credit, you want to keep basically things simple and easy to understand, because especially as you have all these unsupervised algorithms that are quite difficult to interpret, an insight that is not interpretable is actually quite useless. Even if it's correct. If you can't explain it, it's not worth anything. Unless you're a trader, and then that's your job. But even then, you should know what it means, what it means, how you came out about it, what model was behind it. But yeah, so anyway, this is basically a few apps that what we're doing at S&P, and yeah, thanks a lot. If you have any questions, please feel free to ask.
So, these are tremendous visualizations of S&P's data set. But how are you using the huge amount of data you have in machine learning applications to maybe tease out new insights into, how companies or their credit ratings are going to perform?
Yeah, like that's fair. Like we have even in market intelligence, we have tons of terabytes of data, petabytes actually of data. And ratings, I can't really speak for that because I'm not part of the rating business. But in market intelligence, we're actively looking at different, basically, machine learning techniques in order to target areas where we have data around it, but we weren't able to leverage it before. And that doesn't always only cross in credit. So, I mean, the obvious parts of it is like when you think about the call reports we have, text to speech to text translation, things like that that are quite important. And then there's other areas that are more analytical that we're looking into. So we're trying to use our data set as much as we can. In fact, we're able to buy data from third parties, so it's not always our own data sets. Now ratings is completely different. We don't touch that data. That's private. Yeah.
I have a couple of questions. Do you do any kind of bulk outlier detection for the series, maybe for the time series you have? Maybe I missed that. You probably discussed it. And the other thing, do you use any of the fancier, more expensive RStudio products like Connect, Cloud, and so forth?
Sure. Yeah, so for the first one, like I mean, we have multiple different outlier detection schemes. I mean, the credit market explorer piece is using basically biased estimators in order to handle outliers. We literally convert basically a term structure that's explained by, I would say, 3 degrees of freedom into 1 degree of freedom. And then from there, you operate on the level and you trim out basically the outlier so the algo runs by itself without having any human intervention. That's just one example, right, of that case. For our studio, yeah, we have Connect. We're in the process of integrating it into what we call the, basically a larger marketplace or a workplace. My team is switching itself to Connect because right now we're storing things internally in GitHub. But yeah, we do have Connect. And we do have our Studio Server Pro as well. Yeah. And we have Plotly. So that, like, if you want a quick like toolkit that we use, it's really like Plotly, Shiny, you know, Tidyverse. Lately more Python with the whole, you know, TensorFlow, and we've had success using Power BI, the Microsoft tool. Just for some of our analysts aren't technical, and it's very useful for them to be able to drag data into like an easy drag and drop system and just like interact with it, and we've had quite a bit of success with that. So yeah.
Operationalizing, say, a very sophisticated algorithm like a deep learning TensorFlow algorithm. How are you implementing TensorFlow into a real-time report or dashboard?
Yeah, so we don't have a product right now that's using TensorFlow, right? So it's yeah, I'm part of innovation, so I may have prototypes, but we don't have something like that yet. Now, I mean, I don't know. Like it really depends. I mean, we have the ability to like scale up grids, and you know, it's a large company. We can basically use AWS to scale up compute. But I think the commercial side is more where we're looking at, like to see what justifies that investment. In R&D, I can spawn up instances and do it and show the value, but you know, we need to see how much that can actually improve the market. So, but we're looking into it.